Hello and welcome to Kubernetes 101 episode 7. Today we're going to talk about Kubernetes operators, but first, as we begin all these live streams, please feel free to say in live chat or in the comments if you're watching this after the fact, hello and where you're from. It's always great to see so many people around the world watching this, especially on a day like today when, January 20th, 2021, there's probably nothing else going on in the world that you could be paying attention to besides this. But today, there are a few things that I wanted to talk about really quick before we get into operators. First of all, we had a successful BabyWatch. There's a successful production deployment. We have a new baby girl. So thanks for your patience last week. I was in the hospital at the time of this live stream with my wife in labor. So I was not in labor. I didn't do almost anything. She did all the hard work. And so that was pretty cool and awesome. So thanks for coming and watching this. I also ended up getting a haircut. You might be able to notice it seems like half of my hair is missing. It's always nice to do that during this crazy COVID year. It was the first time I went to a hair salon place, or whatever you call those places, barbershop, to get a haircut since COVID began. So it was nice to have that, and my wife didn't have the nervous experience of trying to not cut off my ears and things like that. So today we're going to talk about operators, and these are some operators that you might be familiar with from when the telephone system was put together by people plugging different phone lines into each other. But Kubernetes operators have some similarities. Before we talk about operators, we have to talk a little bit about what we've done in the past few episodes. We had Drupal, and we did a lot of different things with Drupal. We set up resources for PHP, Apache, MariaDB. We set up Ingress to make it connect to a DNS domain name. We set up TLS so that it could have a secure certificate. We set up PVC so it could connect to storage, persistent storage, so it could scale up with NFS. We set up cron jobs so it could do automated tasks. Then we manually installed Drupal. And if we continued down that path, we would also be manually running database updates when we updated the code for Drupal manually. A lot of different things that we do in there. And all of that we had to do by hand. We had to create the manifests, and we had to fill them in, and we had to deploy them. And wouldn't it be nice if Kubernetes could do all those things, the whole life cycle of Drupal or whatever application you're running, automatically? And I have to apologize, but this episode is going to have some jargon, but don't worry about it. When I was writing up everything for this episode, even though I know operators pretty well and have been involved in developing operator SDK and things like that, I still have to look up all the time what all these different things mean and how they fit together. So don't worry about it. Kubernetes is full of jargon, and if you have to look something up, that's perfectly fine. So operators in Kubernetes are a lot like human operators. All the things that we did manually, we can encode in automation code in an operator in Kubernetes and tell it how to do things like deploy an app like Drupal, how to update the app, how to keep it running if something happens externally to the cluster or internally. The operator is able to find ways to react to that and fix things. It can also have intelligence like how to restore an app if there's a failure. If the database server has a problem, we can have code that says, okay, here's how to come back from that problem and restore a database backup or something like that. Now, there are different ways to do things besides operators that you could put into your cluster to do some of these things. But one of the nice things about using an operator, especially if you have certain types of applications, or if you're running hundreds or thousands of instances of this application, you can encode all the logic and knowledge for that application into an operator, so that the operator can handle that all for you. If you use generic solutions from other cloud vendors for things like backups, restores, updates, and things like that, they might not be tailored to exactly what you need. Now, there's benefits and downsides. We'll talk about that in a little bit too. But to understand how operators work, we need to know a little bit about how Kubernetes itself handles the mechanism that operators uses. And there's an analogy that the Kubernetes documentation has about a thing called a controller. And controllers operate inside of Kubernetes on lots of different things for managing pods and jobs and cron jobs and all these different things. And operators are a special type of controller. But the analogy that they use in the documentation makes a lot of sense here. because it helps us to look at something we experience in our daily life, a thermostat and a heating system, or if you're in the southern hemisphere right now, maybe a cooling system. And the idea is you have a thermostat, and the thermostat would be the thing that's a controller in a Kubernetes area. And the cluster would be the heater and the environment that is running. And in this case, we have a gas heater, obviously. If your electric heater is doing that kind of thing, I would definitely get it looked at by a technician. But anyway, you as an end user are going to say, I want it to be about 22 degrees Celsius in here. So you program the thermostat like that. You say, I want 22 degrees. The thermostat tells the heating system, hey, the environment is not 22 degrees right now. I want you to make it 22 degrees by turning on and heating up and doing things. So you take care of that stuff. So the cluster, or in this case, the heater is going to turn on and inject heat into the environment and change the state of it. And then the thermostat is going to keep watching it and say, okay, it's not there yet, keep running. It's not there yet, keep running. Okay, we're at 22 degrees Celsius. Or if it's an intelligent thermostat, it might go up to like 22.9 so that it can stay in that set range longer. And then once it's there, it's going to cut off the heater and say, okay, stop. So a controller in Kubernetes is like that thermostat. It's going to keep informing the cluster of the changes it needs to get to a state that it desires. And then it's going to monitor for those changes to happen. Once they happen, it will stop making changes and it'll stop making the cluster do different things. But it will keep watching and making sure that it's back in the right state. So an operator is very much like that. It's a little bit more intelligent than just a plain controller. But an operator observes things called custom resources. This is a graph I found from containersolutions.com. So this is not my own graph, and I would make it a tiny bit different than this probably, but you can see that the operator is looking at the current state of the cluster and adjusting it over time based on what you want the resources that you create to do. So an operator works with custom resource definitions, and it makes sure that the custom resource that a user manages is controlling whatever things the operator is controlling in the cluster. So if you, we'll have an example in just a minute, but let's say you wanted to have a custom resource for, I mean, technically Kubernetes could manage your heating system. So let's say you have a custom resource called thermostat, and you set that custom resource's temperature to 22 degrees. The operator would say, oh, he wants it 22 degrees. The current state in the heating system that Kubernetes is managing for some crazy reason. I don't think I'd manage my own heating system in Kubernetes, but you know, it could happen. Anyway, it says it's 21 degrees right now, so I'm going to change some things in the cluster to make it get up to 22 degrees. Once it's there, I'm good, and I'll just keep watching for any other changes to the custom resource of the cluster. So anyway, that's kind of how that works. But the power comes in when you see this next slide, and that's something like this. So in the past few episodes, we've been building this one Drupal instance, and we've had hundreds of lines of YAML. We've had to do a lot of different things manually, deploying parts and pieces all over the cluster. But what if you could manage a Drupal site with just this? You could just have one resource definition. It's a custom resource definition, and it's called a Drupal. So in Kubernetes, we've already explored pods and services and cron jobs and things like that. You can create your own resources in Kubernetes using a custom resource definition. And that's part of what you have to do with an operator. You define a custom resource definition, and then you set up an operator to watch that definition, watch for any new instances of it. And then when it sees one, it starts making that happen in the cluster. So in this case, we could make a Drupal operator that watches for Drupal resources, and it creates them based on the spec that you can define. And there's different ways to define the spec. There's very simple ways that are not super robust, but they work. And there's more robust ways where you can actually define the open API spec for them. But in this case, we might have a spec for Drupal where, let's say we have 10 different Drupal sites we're running. And some of them we want to have, they're not quite as important for high availability and performance and things. So it's okay to just have a single MariaDB instance running in the Kubernetes cluster with a PVC backing the data. So we could have a database engine field in the spec, and that would say local MariaDB for these small sites, but we could also have a database engine spec that says AWS Aurora. And what our operator could do is, if it's a local MariaDB instance of a database, it would create that MariaDB deployment in the cluster with one pod running with a PVC. But if it was set to AWS Aurora, it would create an external Aurora cluster and then connect that to your Drupal site instead. So that's some of the flexibility you get out of these operators. You still have to program the operator, but if you manage multiple instances of Drupal, or if you have a lot of complexity in the way you're managing Drupal, you can make it so that end users who are actually deploying Drupal into your cluster don't have to deal with all that backend stuff. You can deal with that in your operator and test it separately. You can also have things like a version tag. If you have one type of Drupal site and you want to be able to deploy different versions, different places, you could do it like that with tags, or you could have an image. So each of your Drupal instances uses its own Docker image. And you could also set up things like, what kind of PVC do you want for Drupal files? Do you want EFS? Do you want EBS if you don't need any scalability? Or you could even say like none if you do something like set up Drupal with S3FS or Fly System, which lets you have all your files stored on a CDN basically, or in a S3 bucket. Anyway, so that's a Drupal, an example of what we could do for Drupal to make things a lot easier to manage for one or multiple Drupal instances in a cluster with an operator. Obviously, I haven't showed you how to build the operator that does all this stuff, but that's the magic that happens, is you don't have to deal with all the components for each site that you're running in your cluster if you can set up a custom resource definition and an operator to deal with it. There are some times when you might not want to use an operator. So for example, if you're just managing one instance of something, like let's say you have one application that you're running in one cluster, and you're not going to have 10, 20, 100, or I've seen thousands of instances of something running. If it's only one instance, it may or may not be worth the effort. If you're going to have one instance in every cluster you run and you're running 20 clusters, that's a different story, because that's a lot of instances of the application to run. And it might be worthwhile to have one operator, and that operator can run in all those 20 clusters. And that way you're managing the one operator instead of managing 20 separate bundles of YAML to deploy it. Another one is I see people sometimes dive into operators before they even have their application running in Kubernetes. I don't like doing that, because like it's hard to know how to encode the automation for your project in Kubernetes until you already have your project running in Kubernetes. And it adds an extra layer of development cycle to work with, because if you build an operator, you have to build the operator, push the image up, and then load the operator into your cluster, or reload it if you're updating it. And then you can deploy your application in the cluster using the operator. And if there's a problem, then you got to go all the way back to where the operator code is, update that, and then push the operator up. It's just a long development cycle. It's a big feedback loop. And when you're prototyping how to build your app in Kubernetes, you want as short a feedback loop as possible. So when I build things with Kubernetes, I always start with the primitives and work up from there. You might also not need an operator if you don't really need that extra automation. If you're just installing your app into the cluster and there's not a whole lot besides that, and maybe updating the tag on it, if it's some really simple microservice and you don't need backups and you don't need restore points and that kind of stuff, or if you have kind of gotten fully into the cloud tool set where you're using a certain cloud provider and you're using all their tools for everything, an operator might not provide as much value for you. There's also a lot of popular operators. Let me switch to Safari. I don't think I do have it running. Okay. There's also a lot of popular operators that if you have been doing much with Kubernetes, you've probably already used some of these. For example, Prometheus, the main way to install it is to install the Prometheus operator in your cluster. And even if you're only running one instance of Prometheus, you install the operator, and then you install a custom resource for Prometheus, and then it builds its own little Prometheus instance for Prometheus and Alert Manager. So that's a pretty popular one. I've also seen, Argo CD. A lot of people use it for continuous deployment in their clusters. And there's an Argo CD operator that's pretty standard and pretty pretty easy and simple to use. One of the preferred ways of getting Argo running. OpenEBS also has an operator, and a lot of times, I think, whoops, I just pasted the wrong thing. For some of these applications like OpenEBS, and I think I was trying to get Rook into a 1-hour presentation a couple weeks ago, but I just couldn't get that done. But Rook has an operator too. A lot of these things have operators because they are very complex, and they have a very complex life cycle of how everything is managed together. And the operator lets the people who maintain these things, like OpenEBS and Rook and Prometheus, encode all that automation into one little application, the operator that's running, instead of telling you to do these 17 steps every time you do an update or something like that. I actually worked on an operator for Ansible Tower, which is another relatively complex, well, I think this thing, it's archived. It's moved to here. It's another relatively complex piece of software. This is the AWX operator. And getting it running in Kubernetes can be a little bit complicated, and doing things like updating it can be complicated. So the operator, again, encodes all those things, like what to do when you update the tag and it has to update the database schema or make changes to the way that the actual deployment is structured. You can get all that working in the operator itself if you have a custom operator for it. One other way to find popular operators is there is a project called Operator Hub, and this is not the exclusive place where you can find operators, but it's a pretty decent listing of operators that are available, and also has like the Prometheus operator and Argo CD and things like that in it. But it's Operator Hub, and I believe that this is maintained by some of the teams at Red Hat, and it one of the goals is to get operators to easily integrate with OpenShift clusters. But any of these operators that could be deployed into OpenShift can also be deployed into Kubernetes itself. But anyway, that's a fun discussion for another day about all the different political background behind the way that operators are developed, the different operator tooling, and all that kind of stuff. I think a lot of the work for operators themselves came out of CoreOS. And if you haven't been involved in Kubernetes development for a long time, CoreOS was actually bought out by Red Hat. CoreOS had so many really awesome ideas for how to do container-based Kubernetes infrastructure. And Red Hat bought out CoreOS and took a lot of the technologies and things that were being developed in CoreOS and kind of adopted them into the OpenShift ecosystem, and still makes it so that a lot of these things are contributed back to the wider Kubernetes community, which is great. For all the things that sometimes we might not like about giant companies with their open source contributions, Red Hat seems to do a good job at making sure they don't just completely abandon certain things after they, for instance, buy out CoreOS or Ansible or things like that. Anyways, we are way off track on that. Before I move on to the next part of this this episode, sorry, the air has gotten so dry in the past week in St. Louis that my throat's like in a constant state of being dry. So bear with me for a second. But before we get to the next part of the episode, I wanted to pause for a moment and give another huge thanks to the sponsor for this series, Amazy.io, and I have their shirt on today, which is a very nice, comfortable shirt. It's kind of a weird year because usually my entire wardrobe is made up of shirts that I got at conferences. And this year I actually had to ask Amazy.io if they could send me a couple shirts because I'm running out, like as you wear shirts, they get worn out. So I'm running out of my conference shirts, and they gladly obliged and sent me a couple of these nice shirts. But besides nice shirts, they have a ton of expertise in managing applications in Kubernetes and deployments and things. And they have a tool called Lagoon, which we're actually going to talk about in a couple episodes. Lagoon is one of the many great tools for managing applications in Kubernetes in a way that somebody like a developer who might not be a sysadmin or might not be that involved in figuring out how to run containers in the cloud, they will be able to manage their deployments and applications and updates and things very easily in a Kubernetes cluster on any cloud provider. Anyways, if you want to learn more about Amazy.io, check them out at Amazy.io. And you can get your enterprise Kubernetes infrastructure up to snuff and deploy applications, especially applications like Drupal that we've talked about, much more efficiently and better. So anyways, now that we know what operators are, we might want to consider how to actually build one. And for that, I'm going to hand things over to Yesterday Jeff. So what if there isn't a good operator for the software you're running in your cluster, or what if your application needs a custom operator? Early on, building an operator required fairly deep knowledge of the Go programming language and the Kubernetes APIs. But thanks to the work by a lot of the community, there are now a variety of ways you can build operators, even if you don't know Go at all. The two main ways I've seen used for building operators are Kube Builder and the Operator SDK. The main difference between them used to be that Kube Builder only helped build Go-based operators requiring knowledge of Go, whereas Operator SDK worked with Go, Ansible, or Helm-based operators. But in the past year, the Operator SDK upstreamed some of its customizations into Kube Builder, so Go-based operators built by Kube Builder and the Operator SDK are practically identical. Operator SDK is still the only easy way to build non-Go operators with Ansible or Helm, though. There are some other projects that help with building operators or operator-like tooling like Kudo, but I won't cover them in this episode. There are a few trade-offs if you're not using Go to build your operator, though. The Operator SDK shows a graph of operator capability levels, and this shows that different types of operators are better at different levels of automation. Helm-based operators are great for basic app install and upgrades. But Ansible operators can perform more automation tasks, like metrics integration, config management, and external integrations. And Go-based operators can do everything with the highest amount of granularity and available performance tuning. But Go-based operators are the most difficult to set up and maintain if you don't already know the Go programming language. And Ansible might be more complex than what you require too if you just want to install and have updates taken care of by Helm. Since I'm most familiar with Ansible though, I'm going to demonstrate building a custom operator in Ansible using the guide from the Operator SDK. First, you need to make sure that Operator SDK is installed on your system. As with everything else on my Mac, I use Homebrew to install it. So I'm going to run brew install Operator SDK. And I already have it installed, and it looks like I need to update my Homebrew, but it looks like I have it installed and it's in the latest version. So I'm all set to go there. And the next step is to actually create the operator itself. So I'm going to create a project directory. I'll call it memcached operator. And then I'm going to cd into that directory. And I'm going to run the command operator SDK init. And this is going to create the operator scaffolding for me. So I'm going to say operator SDK init. I'm going to say use the plugin, the Ansible plugin. And I'm going to give it a domain of example.com. This would be whatever your company domain is or your project domain. For me, it would be like midwesternmac.com. But I'm going to put example.com since this is just an example we're running. And that creates some files in here. You can see it creates a requirements file, a watches.yaml file, a make file, a Docker file, all these different files that are scaffolding that lets Operator SDK know how to manage and build your operator. Next up, I'm going to create an API in the operator. This is what's going to create the actual thing that will allow me to create memcache resources in this case. We're going to build an operator just to build a little memcache deployment in the cluster and manage it, just because it's easy to demo and doesn't require a lot of resources like the Drupal one. So I'm going to create an API with operator SDK create API -- group cache. We'll put it in the cache group and we'll give it a version of v1, kind memcached, and we're going to generate a role that will give it permissions in the cluster when we deploy that role into the cluster. So I'm going to do that. And if I open this up, I might need to make the text a little bigger here. If I open this up, what that generates is all of the configuration here for this memcache operator using a format that will work with the Operator SDK to be able to deploy things in the cluster. And the thing that this gives us is the ability to manage instances of our application using a custom resource definition like this. And we can define any kind of variables we want in our custom resource and pass those into our operator. And instead of having a bunch of Kubernetes manifests to manage, we just have this one simple resource that can say, give me a memcached instance and give me so many replicas, or set it to this version of memcache, or whatever we want. And we can do the same thing for other applications too. I'll talk about that more in a bit. But anyway, the next thing that we want to do is customize this sample operator to actually make it do something. So I'm going to go into into roles, memcached tasks. This is just a little bit of Ansible speak for where's the thing that's going to be run. And by default, it's a role. And we created the role memcached automatically when we created our operator named memcached. And then this is the file that Ansible is going to run when the operator is doing what's called reconciling, or picking up a new instance of something to run. So I'm going to grab the example code from the Ansible for Kubernetes, or the Kubernetes 101 repository, and put it into this file. I won't retype it because that would take forever. But I'm going to grab that example code and paste it in here. And this is the code. We've dealt with these kind of deployments before. It's just a Kubernetes manifest, but it does have a few variables, and these are Ansible Jinja variables, and they look similar to Go template variables that you might use with customize or something like that. But there's a variable for size, and we need to set this up so that we can have users specify how many replicas they want of memcache. So I'm going to go back to the sample right here, and I can put size, and we'll make that 3 for the default sample size that we create when we're testing this out. But this allows people to create different memcache instances in their cluster, and the operator will take care of making sure it has whatever desired number of replicas it wants. Obviously, you can do these things by deploying a deployment yourself, but the operator abstracts that away so that you can say, I want to have 3 baseline replicas, and the operator could in the future do things like add auto-scaling or things like that to it. Anyway, so that's where that is. And then there's also some metadata that comes in, like the name and namespace for the operator for the custom resource that is being created. And other than that, we could make these other things variables too, like if you wanted to allow users to select a different Docker image for their instance when they create a custom resource, or choose different container ports, things like that. But we want to keep things simple here. So I'm going to save this and close it. And then make sure that our spec is up to date, so it has size 3, so that when the operator runs, when we deploy this into our cluster, the operator will run and it will be expecting a size for any instance of memcache that we create. But we don't even have a cluster yet, and we don't even have the operator running yet. So let's go ahead and do those things now that we have this configuration in place for our operator. And the next step is operators run as a container in the cluster. And we haven't seen this in this series, but if you've ever deployed Prometheus or something else, you'll notice that there's an operator pod that's always running in the cluster that's watching the rest of the cluster for any instances of that application. So Prometheus operator just sits there waiting for a Prometheus instance. The operator that we're going to create needs that container image to run too. So we're going to use the makefile that is built with this. If we look at the makefile here, it has some different targets. And pretty simply, you can just build and push a Docker image using this, and then you can also use it to deploy into a cluster, either locally or in the cloud. There's other ways to deploy an operator too, but this is just some conveniences in the makefile if you have access to your Kubernetes cluster. So we're going to make Docker build and Docker push. That's going to build and push the container image. And I'm going to push it into a repository called ttl.sh. If you've never seen it before, ttl.sh is an anonymous ephemeral Docker image registry. I use it a lot for CI instances or when I'm doing a quick demo like this. I would never use it if there's anything secure that you're going to deploy into an image, or if you obviously need an image that stays persistent so you can pull it down multiple times over the course of a month, year, however long. But it is useful for demos and for CI, as long as you don't have any security concerns. So anyway, I'm going to push the image into ttl.sh. I'm going to push it into the name example-memcached, and I'll say keep it around for an hour. So I'm going to go ahead and do the build and push, and it's going to build the Docker image. It's going to push it up into ttl.sh. And after that's done, we can start a cluster locally. You could use Kind, you can use Minikube, you could use a Linode cluster, wherever you want, as long as you have access to it. So I'm just going to say Minikube start. All right, and then I'm going to use another make target, make install, and that's going to install the CRD, the custom resource definition that tells Kubernetes, hey, if you get a memcached instance, here's what's going to handle that. And so the next step is to make sure that we have the image that we just created, that memcached operator image, running in the cluster and listening for CRD instances. So I'm going to say make deploy, and then give it that image again, ttl.sh/example memcached 1 hour. That's our image that we just created. So it creates all these different components of the operator to make sure that the operator can run inside the cluster. And the operator is going to run inside the memcached operator system namespace. There's ways to customize what namespace it might run inside, but the defaults are nice and helpful. So if you say kubectl get namespaces, you'll see that there's this new memcached operator system namespace. And inside there, if I say kubectl get pods-n, that namespace, here's our little operator. It's the memcached operator controller manager. I don't know how many more almost synonymous words we can tack onto that, but it's running now. So it's waiting now to see a memcached instance running somewhere inside the cluster. So let's go ahead and create one. And to do that, I'm going to apply that sample that we had up here. I'm going to apply this resource to the cluster, and it should create us an instance of memcache. And what that instance will be is 3 pods running in a memcache deployment. So I'm going to go ahead and deploy that with kubectl apply-f config samples cache v1 memcached. And that's going to deploy an instance. And while it's doing that, I can watch the logs of the operator itself. And it looks like it's already doing all this work. I can follow those logs if I want to. And you can see that it's doing this. It's reconciling. Reconciling means it sees a change in the cluster, and every time it does that, it's going to look at everything in the playbook that Ansible runs and make sure that it's all up to date how it wants it to be. And it looks like it's finished doing whatever that stuff is now. So I'm going to Control-C out of here, and I'm going to say kubectl get pods and see if we have some memcached pods. And it looks like we do. So our operator is working. It did the thing that we want it to do. And if we want to clean up, we can just delete that memcached instance that we had. I can also say kubectl get memcached, because we added memcached as a CRD. And you can see that there's this memcache sample here. So adding operators with CRDs lets you do this and have your own resources in a Kubernetes cluster very easily. And if you use Ansible or Helm, you don't even have to know Go. It's a really helpful way to do things. But I'm going to go ahead and delete that instance. And I'm going to make undeploy to remove everything from the cluster using that undeploy make target. And this example was kind of simple, but it shows you that it's not too difficult to get started. And even with Ansible, even not having the ultimate flexibility of using Go programming language, you can still do things like create all the proper resources, connect them together if you need to outside of what Kubernetes does internally, run installation tasks, run database update tasks, keep things running correctly if something in the cluster changes, because it reacts to any changes to any of the resources that you're managing. And since operators are basically Kubernetes controllers that interact with the Kubernetes API directly, you can write them in any language. It doesn't have to be Ansible, Go, or Helm, and it doesn't even have to be Operator SDK or Kube Builder. There are also some guides that I've seen online and some other frameworks that you can use to build a controller in Rust or even an operator in Python using something like Kopf. Anyways, I'm going to hand things back over to myself again. It's always a little awkward doing that, but here you go. Thanks again for that smooth transition, Jeff. That'll never get old. Now, there are hundreds of operators out there, and a lot of them aren't listed on Operator Hub, so sometimes it can be kind of hard to find them. For example, this Drupal operator that I've been maintaining apparently for almost 2 years now, I didn't realize it's been that long since I created this thing. There's a lot of operators like this where in my opinion, it's practically production ready, but I haven't set it into like a non-alpha or non-beta tag yet, just because I still have some work that I want to do architecturally to make it work for more of my Drupal sites that I maintain. And but there's a lot of operators out there like this. So sometimes the best way to find if one exists is to just start Googling and maybe look on GitHub for operator and whatever software you're looking at. And sometimes the operators like this one, the last commit was from October. There might be a few things that have broken since if you try running it with the latest version of Operator SDK. But some operators kind of go out of maintenance if somebody stops using that for their management or some things like that. There's no easy answer to how do I know if this operator is right for me or not. But the best answer a lot of times, especially if you need the customizations, is to build your own operator. And things like Operator SDK, Cube Builder, even something like Kudo can make that process a lot simpler. The downside to using one of those tools is usually you have to get locked into making sure that you update things when they update. Otherwise, you might have a huge project of trying to get your operator updated to work with the latest version of the tooling that you're using to build the operator. But anyways, in the end, I think operators are most helpful if you have a lot of instances of an application running and you need to manage all of them, or if you have to do a lot of app lifecycle management for the applications that you're running. In the next episode next week, I'm going to talk about a bare metal cluster on Raspberry Pis. So 2 fun things that I've spent way too many hours of my life dealing with, but we're going to demonstrate getting Kubernetes running on Raspberry Pis in a cluster locally and talk about some of the big differences that you'll have and that you'll run into when you run a bare metal cluster of Kubernetes. And some of the nice things about it and some of the downsides to it compared to running it in the cloud or running a single instance somewhere, because there's always a big difference between running a single instance like we do in Minikube or Kind and something in the cloud or on many instances on a Raspberry Pi. Anyways, until next time, I'm Jeff Geerling.